Sorry about that. All right, excellent. Thanks for the feedback. So let me start over. Apologies for that. So good morning, good afternoon, good evening, wherever you happen to be. My name is Kelly Sturman. I'm the VP of Strategy here at Dremio, joined by my co-founder and CEO, Tomer Shiran. Tomer, say hello to everyone.
Hey, everyone.
We're going to try and make this a little fun and interactive. We got a couple of pictures to show you, talk about the architecture of the product, talk a little bit about why we created Dremio, and then get into the product and show you how it works. Using this tool, you should be able to ask questions along the way. Please do. We'll get to them in the course of the discussion or at the end, seeing how things go. And I have a couple of polls, quick questions. I'll ask you to get a little bit of feedback and insight from you along the way. So if you have time, as I inject those into the conversation, please participate. That would really greatly appreciated. So let's get the conversation going. Tomer, if you want to kick things off.
Good morning, everybody. So what we're going to be talking about here, I'll start with kind of an overview of let's see if this is make sure this is working here.
Okay, now I see your mouse. There we go.
Okay, so we will start with an overview of the company and what we are up to at Dremio. Feel free to use the chat system to ask questions. Okay, so just a few words about the team here at Dremio. So my name is Tomer. I'm one of the co-founders and the CEO. Jacques is he's actually the CTO, not the CEO, but that's
oh, that's my mistake. Sorry about that. Actually, I think Jacques did that.
Oh, he might have done that.
Blame Jacques for that.
So Jacques and I came from a company in the Hadoop space called MapR. I was one of the first employees and the VP of product there. Jacques, you may have seen him presenting at various conferences and events in the big data space. Most recently, he created an open source project called Apache Arrow, which is an in-memory columnar technology that enables much faster analytics, allows the use of modern Intel CPUs for faster data processing, and also fast exchange of data between systems. You may see here at the bottom right, Wes McKinney is an advisor and is the creator of Pandas, a popular data processing library for Python. Wes is also a significant contributor to Apache Arrow. Ajay Singh, for those of you from the Hadoop space, is an executive from Hortonworks, and he is running field engineering here. So Dremio is backed by two of the top VCs in Silicon Valley, Lightspeed and Redpoint. So why Dremio? Why did we start this company and more importantly this open source project? So we're basically there are two trends happening right now in the industry, and the first one across companies in all verticals is the fact that data has grown and it's become extremely complex. It's no longer a world where all data can be stored in a single relational database and you can then simply point your BI tool at that system, right? It's not that anymore. In fact, you know, kind of the traditional stack of ETL tools also struggles to deal with kind of the modern data landscape. And so that's one challenge that companies face, which already is hard enough. But then you combine this with this other trend where the users that want to consume the data, you know, the business analysts, the folks in the business like product managers and other business users, marketing analysts that want to consume data, data scientists, all these people have this great experience in their personal lives where they go home and they can ask a question on Google and get an answer 1 second later. And then they come to work and it takes them months to be able to create a new visualization or a new dashboard or create a new machine learning model. You know, so in our personal lives, we have this instant gratification, this amazing experience with data. And we open our smartphones and use applications to book travel within 2 minutes and so forth. And so this disconnect between our experience in our personal lives and our experience at work with data is just this huge difference. And that also puts pressure on companies to, you know, to be able to solve that problem. So when you combine the growing demand for self-service from the business users and analysts, and the complexity and size of data, you get into this impossible situation. And when you look at the technology stack, that really hasn't changed in 20 years. So what do we do today? We have data in a bunch of different places. Increasingly, we're seeing kind of modern data technologies like S3 and Hadoop and MongoDB and Elasticsearch and so forth, of course, in addition to the relational databases. And then you have the tools that people want to use. And if your company is bigger than a small startup, you probably have more than one tool that you're trying to use. So self-service BI, tools like Tableau, Power BI, and so forth, Click. You have some people that want to use Excel, and other people that are more technical and want to use Python and R for more data science type workloads. And then you have the SQL analysts. So all sorts of different tools that people want to use to be able to analyze data. And so what do companies do? They first move the data through custom kind of ETL development into a staging area. And this is often a data lake, a Hadoop cluster, and cloud storage like Azure Blob Store, S3. It's a lot of work, a lot of scripting and maintenance, and just keeping that pipeline up and running is often very challenging because the data and the underlying sources can change. And the developer who's writing the app on top of Mongo may add a field to one of the collections, and well, how does that data pipeline then deal with that? So those are all things you have to account for. Doing the analysis directly on the data lake is often too slow, as I'm sure many of you know. And so what do? You ETL a subset of that data, maybe the last 30 days, or maybe some aggregate level data into a data warehouse. And that could be something like Redshift in the cloud, or maybe Teradata, Vertica, Oracle, SQL Server on-premise. These are very proprietary kind of lock-in type systems, a lot of overhead, very expensive. And even these systems don't provide the performance oftentimes that the BI user wants. And so then you get into this additional tier of data products. And so you have, for example, cubes with things like Microsoft SSAS or cubes on Hadoop and those types of technologies. And oftentimes we see people pre-aggregate data in the data warehouse, and so they create new tables that are at the aggregate level, maybe aggregated by session ID or by city or something like that. And then you see the people extracting data into BI systems. So these are kind of BI extracts. So yet another set of copies of data. And so at the end of all this, you've paid an enormous price, and that price is not just the infrastructure, of course. You have 10 copies of every piece of data in your company, but it's also the complexity that comes with that. It's also the fact that when you have lots of copies of data, they end up diverging, and in regulated industries, companies get fined for having different versions that have diverged and provide different results. It also introduces security risks, where you now have these uncontrolled copies of data owned or managed by different departments or different end users who may not have that same kind of expertise as IT does around data security. And then finally, I think the most problematic aspect of all this is just the fact that you cannot accomplish self-service when this is the data architecture. Because when you have different pieces of your data living in different systems and in different types of structures, it's impossible to expect that Tableau, Power BI, Click user to know where do they go to analyze each data set. So, maybe that sales data, if it's just a very simple sales data analysis, they can go to that cube, but then they want to join that with the session data from the website, and they can't do that, right? And so at the end of the day, the vast majority of companies today, when a user wants to do something new, ask a new question, create a new visualization or a new dashboard, they are dependent on IT, right? So they file a ticket, they wait for IT to go prioritize it, and finally maybe a month or several months later, everything has been done, and there's some table in some data warehouse where they can point their BI tool at and start querying the data. So very, very complex, cumbersome, and hasn't changed in 20 years. And our belief at Dremio is that in order for companies to become data-driven, which they all want to become, this cannot continue to be the architecture. It just does not work anymore. And that's the reason we started Dremio. We really felt that there had to be a better way. We thought that if we built an open source project that really addressed kind of the modern landscape, then we could we could really empower data consumers, those people that are using BI tools or doing machine learning, to be self-sufficient and do it in a way that IT feels comfortable that they have that kind of governance and control around that self-service work. So what do we mean by a better way, right? So first of all, we think it has to be something that would work with any data source. So most companies have lots of different data sources today, and we know that 5 years from now, there will be a new set of data sources which we can't even name today. Just like 5 years ago, nobody was using Elasticsearch or MongoDB, or very few people were doing that. We think that it has to work with any tool, any BI tool, any data science tool, things like Tableau and MicroStrategy and Excel and Python and so forth. We think that the world would be a better place without ETL, data warehouses, and queues. And we understand that you can't get rid of all that in a day, but we think that those systems are there. They're kind of a necessary evil today, but there has to be a better way, and nobody really likes having to manage those. We're big believers in self-service and collaboration. One of the things you'll see about the user interface is that it very much resembles Google Docs, except for instead of documents, it's data sets. Performance is key to all this. If you make something that's not fast enough, nobody wants to use it. And so we've spent a lot of time and a lot of our IP in technology that makes things go faster. And if you've ever used kind of BI on top of big data and seen that queries take 10 minutes to come back into the BI tool, that has to be solved, right? We have to be able to provide an interactive experience of 1 or 2 seconds, even for the largest data sets, even for petabytes and many, many billions of records. And then finally, we think that it has to be open source. It's 2017, any kind of data infrastructure or analytics technology needs to be open source. Companies don't want to get locked in. They want to have a healthy ecosystem around the technologies that they use. And that's really core to what we're doing here. And you may have seen every member of the executive team at Dremio comes from a company that has built a successful open source business, whether that's Hortonworks or MongoDB or MapR. These are all companies that have grown from 0 to over 500 employees. So what is Dremio? It's a new tier in data analytics. We call it self-service data. And what does it do? Well, it provides everything that you need in between where the data lives and the tools that people want to use on their desktop to explore and analyze that data. And when we say everything you need, that includes kind of the logical aspects of it, meaning, for example, the ability to find the data that you want with an integrated data catalog. It includes the ability for people, whether they are technical or not, to curate new data sets, and we call them virtual data sets, by interacting with the data and transforming columns and joining things together. And then at the physical layer, being able to connect to all these different data sources and run queries that join data from different sources, and of course, accelerate those queries. So like I said, when you have petabytes of data or terabytes of data, you still have that need to come back and provide results to a query in less than a few seconds. So how do you do that? Well, we've developed a unique data acceleration layer, which we call Data Reflections. So let's talk a little bit about the technology and how this is possible, right? Oftentimes I talk to people about this, and it kind of seems like the holy grail. Well, how is this possible, right? And a lot of technology goes into making this this kind of a reality. The first thing I'll talk about is kind of just one of the things. The first things you'll see in our demo is that user interface and everything behind the scenes that's making this possible. And so we like to think about it as similar to Google Docs for data, where people can collaboratively work together. They can create new virtual data sets. It's not like data preparation. We're never creating copies of that data when you create when you curate the data. It's all live data. You can create millions of these new data sets, and there is no problem. And then the second thing is that ability to perform live data curation, right? You're always operating with live data, and that experience is powered by the Dremio Learning Engine, which is our AI kind of backed engine. So what does that engine actually do? Well, one of the interesting things here is that the Dremio curation and collaboration interface, as well as all the queries that are coming in from client applications, are all received and processed by Dremio. So we are the execution engine for these queries. And that means that as things are happening in the system, whether it's through our user interface or through one of these BI tools, we are learning from those queries. So we're learning, what are people joining together? What, we'll see that somebody, many people are, for example, joining one table in SQL Server with this specific Hive table. And so now we can recommend that to other people. We call that predictive transformations, where we're recommending a transformation that somebody may want to do. And again, the unique advantage here is that because we are the execution engine, these recommendations are not just based on other people's kind of preparation experience. They're based on the actual analysis that happens in the BI tools. And they are also based on us seeing that data over and over again as queries are running in the system. And we also have an adaptive schema learning system here, where if you've ever used any other kind of product in this space, you'll know that you have to define schemas and mappings and things like that. None of that is necessary in Dremio. We automatically learn the schema from every system that we interact with, whether that system has a well-defined schema in it, like a relational database, or maybe it has less of that, like MongoDB not having any, or JSON files in a directory on S3. There is no schema there. We have a predictive metadata caching layer, where we are automatically, based on the query patterns, figuring out what do we learn more often versus less frequently. And then we have a lot more coming here. In our next release, we'll have predictive kind of SQL recommendations. So in terms of the deployment reference architecture, Dremio is basically open source software. You can download it. It's a distributed system. You run it on anywhere from one server to thousands of servers in a single cluster. You have two options. You can run it in the cloud, or you can run it on-premise. I'd say about 50% of our users run it on kind of EC2, whereas others run it in their own data centers. We have a persistent caching layer, which we call the reflection store. And that reflection store is a really key ingredient in enabling interactive speed on very large data sets. And that reflection store, we can maintain these data reflections either on S3 or on HDFS or on direct attached storage. So basically the local disks of the Dremio cluster. Our interaction with the underlying data sources allows us to push down query processing into these sources. So we've spent a lot of time integrating with these technologies, things like Mongo and Elastic and relational databases and Hadoop. And we know how to, for the systems that have execution capabilities, even if it's not full SQL, we can push down processing of relational query plans into those engines to the extent that it is possible, right? And then we augment it with our own capabilities. So you have a full SQL experience, including joins and correlated subqueries and window functions, everything you'd expect from a fully compliant SQL engine on top of systems that don't even do SQL, like Elasticsearch and Mongo and others.
So we have one question that's probably good to talk about right now, which is, what is the impact of pushdowns on source databases? Mm-hmm. So I think it's good to talk a little bit about how we really do push down predicates and other expressions when appropriate to make those queries as efficient as possible in the underlying system. But that if you want to minimize the impact of queries, you can use data reflection. Right. Talk a little bit about that.
Right. So, yeah. So, it's really a question of what do you want to do, and what are these databases that we are connecting to? What are they actually serving today? Because Dremio gives you a lot of flexibility around how we interact with those systems. We can operate in kind of full push-down mode, where basically we're pushing down as much as possible into the underlying source. And that's great if that underlying source system is kind of designed for analytical type workloads, right? Oftentimes, say an Elasticsearch cluster, it is there to serve analytical workloads. It has the data indexed, and when we push down a group by on an indexed field, it can return a response very efficiently. In other cases, we may be connecting to your OLTP database, the one that's processing your orders and your e-commerce transactions. And in that case, it may be less than ideal for us to be pushing down kind of large analytical queries into that source system. And that's where these Dremio, our data reflections come into play. So the data reflections that sit in this reflection store can actually, from a physical standpoint, they can mask that underlying source, so that we actually never talk to that source except maybe on an hourly or daily basis to bring in the incremental changes that have happened in that source into the Dremio persistent cache. And that allows the user to have that experience of, I am interacting with any data at any time, doesn't matter what system it's in, while at the same time kind of isolating those operational databases from these analytical queries. And so you kind of have that flexibility. We'll talk more about reflections and in particular the raw reflections that we provide, which are kind of row granularity data reflections. Those are the ones that can really prevent any query from hitting the operational database. Okay. So we optimize your data and your queries for acceleration. And there are a number of kind of technologies in the product that enable us to provide this level of performance. And we talked about the native pushdowns. That's the one on the bottom left here. But there are a few other things. And so first of all, the execution engine in Dremio, it's a distributed engine. It is actually based on Apache Arrow, which is now the kind of the underlying technology for some of the GPU databases. And Python and R have also embraced Arrow as kind of their in-memory high-performance data representation. And so being based on Apache Arrows allows us to execute extremely fast and leverage the modern CPU kind of SIMD vectorized kind of operations that Intel CPUs support. But beyond that, that's often not enough, right? Just executing fast on a lot of data is not sufficient in order to provide interactive response time just from a physics standpoint. And so that's where really the key here is the Dremio Reflections. These are optimized physical data structures that allow us to satisfy queries much, much faster by reducing the amount of work that has to happen in order to respond to that query. And so if you think about kind of traditionally technologies such as cubes and projections in some databases and indexes, all these types of techniques are about optimization of data. And so Dremio leverages those types of techniques, and it does that in a transparent way where the user who's running a query now across maybe multiple sources or even just on their data lake doesn't know about these data reflections, and their queries get magically accelerated from their standpoint. And the reflections also allow they also allow the kind of the administrator of the system to then add additional optimizations for new workloads and new use cases that people care about without any impact. So this is what the reflections look like. So if you think about traditionally how people approach this is they create aggregation tables or cubes, right? That's kind of what they create, and then the administrator designs and maintains those physical representations of data. That's what you see on the left. Unfortunately, the user then has to pick the right representation that they want to interact with, which in any real world scenario becomes impossible because the user doesn't, the user can't look at 1,000 tables in the data warehouse and say, you know what, this is aggregated by session already, and I really need session level information is enough for my query, so let me go over there, right? There's no way they can be that sophisticated and always know exactly what the physical representations of data are. The difference here with Dremio is that you may have, with a source table in Dremio, we will design and maintain different physical optimizations of that data, whether they're sorted by specific columns or partitioned in different ways or aggregated by different dimensions. And when a new query comes into the system, whether it's through a BI tool or through somebody writing SQL by hand, we will automatically pick the right set of physical optimizations or data reflections in order to accelerate that query. And we will internally rewrite the query plan so that instead of going through the raw data for every query, we are now using these data reflections and substantially reducing the amount of work that has to take place in order to respond to that query with the correct answers. So with that said, let's look at the product.
Actually, let me run a couple of quick polls. Be great to get feedback from you folks on the call. The first question is just about the tools you're using. Please, it's multiple choice, so whichever apply to you, it'd be great to just check those off, and we'll make sure. It's just interesting to see what tools are being used right now. And while you guys are voting, one quick question that came up was, where are these reflections stored?
That's a great question. So the reflections are actually stored. You have several options of where that reflection store lives. It could be if you do have a distributed file system such as HDFS or MapR or a cloud access to cloud storage like S3. then we can store these reflections inside of that persistent store. And the great thing here is that they do not have to fit in memory, and these storage technologies are extremely cheap. Now, sometimes you are running in a situation where you don't have access to cloud storage, so maybe you're running on-prem, and you also don't have a Hadoop cluster anywhere near. And that's okay as well, because Dremio can actually store these reflections just across the local disks of a Dremio cluster. We can stripe them across those disks, and we don't really need that data to be replicated because we're not storing the primary copy of the data. It's really a cache.
Okay.
So that's the other option.
Great. So I'll wrap up this one. I have one other quick question, which is more about the sources of the data that you use. So again, it's multiple choice, so just pick all the ones that apply to you. It's just interesting to see what sources are people using and that are important in terms of analytics. And while that question is, while you guys are voting on that, again, I really appreciate all of you. I think we've answered this question. Another question is, how do you keep these reflections current with respect to the source?
Yeah, so the way we keep the reflections current is you basically, you can define the SLA. So you may say, you know what, I'm okay with the data being up to 1 hour stale, right? And then we will figure out the right kind of update orders and refresh these reflections automatically. And we'll do it in an intelligent way where internally we build kind of a reflection graph where we can decide to update one reflection and then based on that update other reflections that are actually can be derived from that first one. So that can also reduce the load on if it is an operational database and not like a data lake scenario. You can also choose whether you want to do these incrementally. So we have an option for incremental refresh, and we also have an option for kind of a full refresh on that schedule. Great.
Thank you so much. All right. Last quick question. And again, this is just another multiple choice. Which role best describes you, those of you attending on this call? I realize that some of you probably fill all of these. I know I feel like I do most days. So really appreciate the feedback. It's very interesting to see. Okay, Tomer, take it away. Let's see if there's any other quick questions that we can answer. If you're running Dremio in Hadoop, does it need to run standalone or can it run on existing nodes?
So when you have a Hadoop cluster, it is most typical that you would run Dremio inside that Hadoop cluster. And we actually integrate natively with Yarn, and we allow you to use Yarn to provision the Dremio executors on your Hadoop cluster. So really, in terms of hardware, all you need if you have Hadoop is one or maybe a few edge nodes where you can install the Dremio coordinator on, and then we will actually run the execution inside of the Hadoop cluster leveraging Yarn.
Okay. Thanks everyone for voting on those 3 polls. Tomer, let's jump into the demonstration. Let people get a close look at Dremio in action.
Sure. So what you're seeing here, actually, if you're looking at my screen, is the user.
Actually, I don't see your screen yet.
You do not see it?
I see. Hopefully, the demo is more than just a slide that says demo.
Oh, that's. I think it is. Okay, I think we're sharing the application. Let's go to sharing the. We'll do a new share. So I'm going to go share my entire desktop here so I can kind of show you how it interacts with the BI tools as well.
Yeah, that sounds good.
Okay.
Yes, I can see it now. Looks good.
Okay. So what you're seeing here is the user interface of Dremio. So when you log into the product, this is what you'll see. And the first thing you'll notice on the bottom left here is we have our data sources. So we have, in this case, this cluster is kind of a mess. It has all sorts of different sources that, in fact, different people here have added at Dremio. So I have an Elasticsearch cluster and a MongoDB cluster and some Postgres and what is this S3 account? So S3, I have all the buckets that different people here have created. So really lots of, I have a Hadoop cluster here as well. Lots of different sources that I've added to this cluster. Now I'd say about half of the our users kind of focus on one primary source. Typically, that's their data lake, either Hadoop or kind of an S3 data source. And then the other half are typically they have multiple different sources of data, and they're seeing the value in kind of bringing together data from different sources. Okay, so that's what you have here at the bottom. If I click this plus icon here, I'm an admin, so I can do this. You can actually add new data sources, and adding a new data source is as simple as selecting that source and entering the information about it. So, if that's an Elasticsearch cluster, let's say, I click on Elasticsearch and I can enter the credentials and the hosts, and that's about it. We actually discover all the nodes in the Elasticsearch cluster automatically if you enter one of them. Okay. So what you see on the top, on the left-hand side these are called spaces, and spaces are a way to organize virtual data sets. So as users in Dremio create new virtual data sets, those can be stored inside of or saved inside of spaces, and that's also a way to kind of set permissions and sharing, where you can say, you know what, I am going to share only one specific space of curated data with no PII information with my kind of junior analysts, and maybe I'll create a different space with other data sets for other folks, and and they can also create their own spaces and collaborate. And then every user also has their own kind of home space. This is what you see at the top left, where you can create your own virtual data sets. You can also actually upload your own spreadsheets. So if you wanted to take a huge data set in Hadoop and join it with a spreadsheet that had the list of the 10 customers that you care about, you can then join that very easily, those two data sets. Okay, so let's look at a simple kind of example here, and let's create a space for the purpose of this demo, and we'll call this the let's call this the webinar space. So what we see here is webinar, and that's a new space that we have here, and you can see that there are no virtual data sets inside of the webinar space. So now let's go and start curating data. It seems like my laptop here is spinning its CPU for some reason. Maybe this webinar software is kind of slowing things down. So typically this is extremely fast, and so it may be a little bit slower here because of that. But when you click on one of these data sets, what happens is that we show you the records. So I've clicked on this data set of businesses inside of the MongoDB Yelp database. So you can see here on the top left, this is a purple table icon. That means this is a physical data set. It's one of the data sets in your source systems. We never change that data. Every data set in the system, whether physical or virtual, has kind of unique coordinates. This one is mongo.yelp.business. And when you query data, if you're technical, you can actually see the SQL. And so this one is select star from mongo.yelp.business. But let's close that, pretend we're non-technical users and we just want to interact with the data. So, this underscore ID column, I probably do not care about it. So let's just drop that, click on drop, and we can drop that column. We have the cities here. These are actually, every record here is a business in the United States, and I may not care about all the cities. And so let's click on keep only, and keep only a subset of the cities in this data set. So it looks like Pittsburgh and Charlotte are the most common businesses. Let's focus our analysis, or the most common cities. So let's focus our analysis on those two cities and click on apply. And let's see, what else can we do here? So let's say I wanted to figure out what are the most common business categories in these two cities. And so you can see we have the categories here as an array. And so every business has potentially multiple categories, and that's not good in terms of being able to do a group by and do this analysis in a BI tool. So what I could do here is I could say, you know what, let's click on this and unnest this array. And so I'm going to basically unnest the array so that every category shows up in its own record. And I can go here and I can type here and just rename the categories column to category, because we now have one category per record. So I've made all these changes, and actually, of course I could have done that as a non-technical user. That was very, very easy to do. If I can use Excel, I can use Dremio's user interface here. But if I am technical and I want to do more sophisticated things, I can actually use the SQL editor, and I can use I have the full range of SQL. So you'll even notice here that as you made these changes in real time, we are updating the SQL. So you'll see things like where city in Pittsburgh and Charlotte, right? Those are the things we did in the UI. So let's go ahead and save this inside of our webinar space. So I'm going to click on the Save As button, and we're going to save this inside of our webinar space, and let's call this the categories data set. Once I've done that, you'll notice the icon changing from purple to green here, which indicates that this is now a virtual data set. It's called webinar.categories. And so I can now play with this data set. In fact, I could even run a query that joins webinar.categories with something else. We also have these buttons here, which make it very easy to open a BI tool with a live connection to Dremio and to this specific data set. So in this case, we are opening up Tableau with a live connection. We never export the data from Dremio into the BI tool. We're just basically launching the BI tool with a live connection. So from the BI tool standpoint, Dremio looks just like one relational database. We accept SQL queries, we run them, and we return results. And so here you'll see I've opened up Tableau Desktop by clicking on that Tableau button. And on the left-hand side here, what you'll see, for example, that there is a column called category. And so this is that new column that we literally just created 1 minute ago, and flattened the JSON and so forth. So that's how easy it is. I can now start dragging category and playing with this data set inside of Tableau. But let's look at a more complex example here where I'm joining data across multiple data sources. So let's look at this data set inside of Elasticsearch, where I have all the reviews on Yelp. So this is the review data set. So this is actually in Elastic terminology, review is a type and Yelp is an index. And again, you can see we happen to name this thing Elastic-remote. I guess it's sitting remotely from our Dremio cluster in this case. And one of the most important columns here is the text column. That's the column that has the actual review. So, for example, a nice venue, good food, great beer, awful service. Okay, you can see they gave him, that person gave this a 3. Venue was nice, the service not so much. And if I open the SQL editor again, you can see that when I just clicked on this data set, we started off with just a select star. Now, if I'm technical, I can start typing SQL here, where and actually for things like Elasticsearch, we support a function called contains, which allows us to do free text search. And so we can push down any Lucene expression. This is actually a Lucene expression here. We're pushing that down into the underlying data source, in this case, Elasticsearch. So now you can see, if you look at the text column, we see amazing all over the place, right? We're looking at all the reviews that have the word amazing in them. So amazing food and coffee as an example. I can now click on the join button, let's say, and we will recommend things you might want to join this with. So even though we've transformed the data set already, by filtering for, only the amazing data sets, and it's now, it's not even a named data set at this point in time because we haven't saved it yet, we can still identify the right thing to recommend that you join it with. And in this case, the top recommendation is this data set of businesses inside of Mongo. Okay, and the reason we're recommending this is because we have seen other people do this join from queries, SQL queries that have been received from various BI tools. And so I'm going to click on apply. If this was the first time using the system, I could have just done a custom join and have that visual drag and drop experience that you typically see in a lot of products. You can also see the history here of all the transformations that we've done, and you can go back in time if you want to. But let's go save this data set now, and I can save this inside of the webinar space. So I'm going to save this and call this the amazing reviews. Now, if I click on this data graph icon, one of the cool things you'll see is you can actually see that data graph. So you can see that the webinar.amazing reviews data set hasn't been queried yet. You can see 0 jobs, but it is derived from these 2 data sets. This Yelp review data set in Elastic, you can see it comes from Elastic, and this Mongo Yelp business data set that comes from MongoDB. And you can see how many times these data sets have been queried directly, and it's actually quite a bit. And in fact, I can click on one of these things and kind of focus the attention to that specific data set. What happens is that data set then moves to the middle, and you can see, that this data set here of Netflix.goodreviews is actually based on this review data set. So I can look at that. I can also click on this jobs link here at the bottom, the 4, and see, what were the actual 4 queries that ran on this Netflix data set. And I can actually see that Kelly here has been playing with that data set.
I can't get enough of those reviews. Keep going back.
So if we go back, let's go back to the main screen here and look at our webinar space. And what you'll see here is you'll see two data sets that we created throughout this demo, right? So early on, we created this categories data set. Now we created amazing reviews. Amazing reviews, again, was that join between Mongo and Elastic. And again, I can open this up in a client application. I like using Tableau on my desktop just because it's very, very lightweight. So I'll spin it up on my laptop. Again, my laptop is pretty slow, so it's taking Tableau some time to kind of open up here. But what you'll see here is Tableau connected, and here at the top you'll see webinar.amazing reviews. Okay, I can start dragging and dropping. So I may say, you know what, I want to see the names of the businesses that have the most reviews with the word amazing in them. So I'm going to drag that here. What happens when I drag that here is that Dremio is getting a, I'll show you here, we're getting this query from Tableau. So you can see select star. This is the query we just got. It was a simple group by from Tableau. I can drag the number of records here to see actually how many reviews with the word amazing did we get. And you can see it only takes about 5 seconds to, for us to parse the query, plan it, and then push down the query, two different queries, one into Elasticsearch, one into a remote Elasticsearch cluster, one into MongoDB, and perform an in-memory distributed join and return the results back to the client application. And so you can think about how hard this would have been if I had to export data from these two different NoSQL databases into a Teradata system, and then point my Tableau at that Teradata system. That would have been a project that probably I could have spent the whole week kind of planning out and making sure that also keeps working over time. And so I was able to do that here in just a couple minutes. And you can see that Monabi Gabi is a restaurant that has the most reviews with the word amazing. If I wanted to see, let's say, I keep playing with this. I always enjoy just doing random things with this data. Let's see what the cities are. I'm curious what. And this one, I guess we did not filter by those two cities, so it'll be interesting to see what are these. So actually, these
Pita Jungle. Wow, they're all over the place. I've never even heard of that.
Oh, this is a chain. Yeah, it's in Scottsdale, Phoenix, Glendale, Chandler. Okay, lots of Pita Jungle. That seems like a kind of a chain restaurant. These other ones seem like there are these businesses, Wicked Spoon. They're all single city. Actually, this one has a Henderson. In addition to Las Vegas. Anyway, so that's kind of how easy it is to work with data across different sources. The last thing I want to show you, those data sets were not very big, right? So oftentimes you're going to get into situations where you have big data sets, and these are data sets that may be using a SQL engine like Hive or Athena. It would take you maybe many minutes to run these queries on larger data sets, and so that's where Dremio Reflections come into play. And so let me, as an example, show you this data set we have here that has over 1 billion records. And we're actually running on a very small cluster. So 1 billion records on this cluster takes about 10 minutes, or let's say 6 to 10 minutes, depending on the exact SQL engine and the query that's being run. And what I want to show you here.
And by that, for 6 to 10 minutes, you mean if you were going to query this with Hive or Paula, that's the kind of latency you would see in this cluster with this data.
Right. Of course, you ran a bigger cluster, it'd take less time, but it all scales with the amount of data and the amount of nodes that you have in your cluster. So what I'm looking at here is a data set that has all the taxi trips in New York from the last something like the last 5 years, I think. And so you can see the pickup time, the drop-off time, number of passengers, trip distance, and so forth. I think this data set actually, well, it's not I think, this data set actually sits inside of a Hadoop cluster on HDFS. So again, every time I drag the mouse here, this would be about a 10-minute wait. Okay, so let's see what it looks like when you're using Dremio and we are taking advantage of data reflections behind the scenes. So I'm going to drag the number of records here, and you can see that we just performed a count star on 1.03 billion records, and that came back in less than a second. And I can do whatever I want. I can take the drop-off time, and I can see, okay, when are the taxi drivers dropping off the passengers? So let's turn that into a bar chart, and you can see here 2012 to 2014. Now we're seeing kind of a decline in the number of yellow cab taxi trips in New York, and that may be because of kind of Lyft and Uber taking some of that load. We can let's say we wanted to look at the tips. I was like looking at tips and amounts that people are paying. So actually that needs to be an average, not a sum. So let's change that to average. And every time I'm interacting with this, every change, changing from sum to average, and if I wanted to look at, let's change the colors here. All those interactions were resulting in a SQL query being sent to Dremio. And so you can see the tips have gone up from 2009, which you may recall was that first year after the Great Recession, up to 2014. So maybe people are feeling better, they're tipping more as the years progress. Let's see if we can see any trends in terms of the months. So when we look at the months, we see that if you wanted to be a taxi driver, I would recommend being a taxi driver later in the year. It seems like maybe people are spending all their money, or they're feeling good, tipping the drivers up until kind of the holiday season, and then come the new year, everybody's in a bad mood and the tips go down. And they start going up again, and then July comes around, and a lot of tourists are in town, and the tipping goes down again. So I don't know the exact reasons for this, but what I can do is I can kind of play with the data, right? And I can get these trends very easily because I have that ability to get this interactive kind of experience rather than waiting 10 minutes every time I drag the mouse. If we go here into the jobs page, what you can see all these queries that have come in as I was demoing that data set. And so you see all these sub 1 second queries and the flame next to them. And so we would have, unfortunately, this would have been a 3-hour webinar had we not had data reflections here, with each query taking us 10 minutes or 6 to 10 minutes from our experience. But because of our ability to accelerate these queries, and that little flame indicates that, we're able to play with the data in a much more interactive way. So that's kind of the experience with acceleration.
Let's see if we can make sure we understand. So this query that I'm looking at, this big select average from group by, et cetera, that's down there on the bottom of the screen. That's the query that Tableau sent over ODBC to Dremio. And what happened to the query after it got to Dremio?
Yeah, so when that query hit Dremio, the first thing, we have kind of a unique cost-based optimizer that took that query, parsed it, turned it into a kind of a logical query plan. And then we ran some unique algorithms that we've developed here, which basically looked for opportunities to not have to scan the entire New York City trips data set. So this is really what the user is asking us to, go query this massive data set of 1 billion records, right? Now with our algorithms, we have identified that we actually don't have to go scan that entire New York City trips data set. We can instead leverage some of these data reflections that we have in the cache where the data may be pre-sorted or pre-aggregated in different ways, and therefore reduce the amount of time that it takes to satisfy this query. And in this case, it was, I guess 600 times faster.
Yeah, something like that. Okay, so we have a bunch of questions, a lot of really good ones, and some fun comments. I especially like the comment, "This is freaking awesome." I agree. That's why I get to work here. So let's get through a couple of these questions.
Read some more of those types of comments.
If I want to visualize Dremio tables with a non-Tableau SQL compatible tool, what connection types or drivers would I need to use?
Yeah, we actually, if you go to our website and you go to the download page, you can download the Dremio ODBC, JDBC drivers, and you can use any SQL compliant tool. It doesn't. I was just showing Tableau because that's what I have on my laptop. I could show you just as easily, Power BI, Qlik, MicroStrategy, any of these other tools.
Okay, another question is, when I'm pulling data from an RDBMS, is it stored on Hadoop in Arrow format? So I think what they're asking is, if I create, right, because if you don't have to move the data into Dremio, right? We run between your tools and the data, but if you create a reflection on data in a relational database, how does that get stored in Dremio's reflection store?
Yeah, so Dremio, all Dremio reflections are stored in a highly compressed columnar representation. That's kind of the foundation for that. And so we leverage Parquet, Apache Parquet, as well as Arrow, and we've introduced additional optimizations on top of those things in terms of how we deal with the dictionary encoding and all sorts of statistics that allow us to be more efficient when we actually run the query. So for example, we don't want to decompress or deserialize that data when we don't have to. We can run the entire execution without doing that. and that's of course even better. So that's how the data is stored. It's stored in a highly compressed columnar format inside of the Hadoop cluster if Hadoop is being used as your reflection store.
Great. And you know, another question related to this is would it be faster to have the reflection store be S3 or HDFS or the local file system? Are there any differences in terms of performance there?
You know, that's a really good question, because at the end of the day, you know, we have to read that data, right? So the performance at which we can read that data, you know, that will play a role, right? Especially, and it depends on what kind of reflection we're using. We spend a lot of time integrating well with all of these different systems. So S3, you know, will open lots of different parallel connections, and you know, and we'll do the same thing, of course, and get data locality even in the case of HDFS. So then it becomes, okay, well, how many disks do you actually have in that HDFS cluster versus, you know, the performance of S3, and the instance types you're using on Amazon dictate the throughput that you have to S3. So unfortunately, I can't really answer that question, because it kind of depends on the exact, you know, instance types or hardware that you're using. We have users that use either of those and have good experience.
But I think a key thing is that it doesn't require, you know, super high performance storage subsystem to get the kind of experience, the kind of experience we just saw, right? What we just saw was Dremio running in a Hadoop cluster on Google Cloud with cheap cloud storage underneath in this particular cluster.
Yeah, we were just using local instance storage.
Yeah, so there may be some differences between S3 and HDFS, but that's not going to be this massive difference. The big advantage here is the fact that we're using reflections in a highly optimal data structure that makes it so you don't need super high performance storage systems. Another question is related to reflections. How are how are the reflections updated over time?
So the reflections are updated effectively on a schedule. You know, so you can kind of define for a given source, you can say, what is my SLA? How stale is this data allowed to be, right? But then it's a cache, and so when we use reflections, we're not serving the data from, you know, 1 second ago. We may be serving data that's a minute old or, you know, 15 minutes old, but you get to define that kind of what that period of time is, and you can actually define it for different sources of data at a different threshold, because and also for different physical data sets, you can have different thresholds.
Okay. How does Dremio manage access control?
Yeah, so access control, well, there's two aspects to that. Let's start just with authentication. So authentication, you can either define the users inside of Dremio, or you can have us connect to your LDAP source, so Active Directory or just any other LDAP. That's for kind of identity, and that's how we check the password, and that's the group membership information that we use also comes from LDAP if you're connected to LDAP. When it comes to permissions, you can actually see that here. So when I'm not sure you remember, but when we created that the space called let me click on the spaces here. When we created that webinar, oh, that's the top here. We pinned that to the top. So when we created the webinar space, we actually had that ability to say, who do you want to share it with? Now, I was kind of lazy and I just shared it with all the users, but you could go here and share it with specific users. So, you know, maybe I wanted to share this space with Kelly. And so now only myself and Kelly have access to this space here. So that's kind of you can do it at the space level. You can also go and do that at the data set level, and you can override it. So depending on your company and your exact situation, you may actually decide that you don't want to expose the you know, the sources of data here at the bottom left to your end users, to the let's say the analysts. You may say, you know what, I want only IT to have access to the raw data. And in our company, what we'll do is we'll create a space with the IT kind of IT approved data sets, and that will be kind of the starting point for all the users. So maybe you just drop some of the PII columns, the social security number, the credit card number, or, you know, only decide, you know, to expose a very small subset of the data to your end users. And they can build on top of that. They can, you know, people can build virtual data sets on top of other virtual data sets. But permissions really allow you to control who can see what data. And you can also do things at the column and the row level as well. Okay,
so what about Kerberized Hadoop? Is that supported?
Yeah, that's supported. There's no problem. You can and there's documentation on how to do that.
What about user delegation?
Yep, we will actually, when you add a Hadoop source, there's a checkbox that says, do you want Dremio to impersonate the user? Meaning, should we be talking to the Hadoop cluster as the identity of the user who is connected to Dremio, or should we be talking to the Hadoop cluster as the Dremio user, or whatever user you said you're running the Dremio daemon as? So
okay,
you have that option.
Several questions related to sources that are supported.
Mm-hmm.
So what's there today, and what's sort of the story for the future going forward?
I think we have a dozen. Let's see. Well, I'm doing some multiplication here. So 13 sources today, and so HDFS, your Hive tables. We don't use the Hive engine. We're using this is like the Hive Metastore, MapR, SQL Server, Oracle, network attached storage. You can use any number of NAS solutions here. MySQL, MongoDB, Elasticsearch, and HBase are the NoSQL databases we support now. We have some of these coming soon icons at the bottom, although we've now, it'd be more fair to say we've gotten a lot of requests for, can we add this data set and that data set, and we'll continue to add, new data sources, and we'll continue to add more sources to the system as we're getting these requests. So that includes Teradata, HANA, various cloud applications, which we'll be adding as well.
What about MapRDB?
Yeah, that's another one where we've had multiple requests for MapRDB, including both kind of binary as well as the JSON document model, and we'll be adding both of those as well.
Okay, so we're running out of time, and again, I really appreciate all the great questions.
And I'll just add to that. Feel free to reach out if you want specifics on talking about specific items and roadmap and dates and so forth. I don't want to get into all that now, but we can of course have that kind of one-on-one conversation.
Why don't you open up the community site just so people can see that?
Oh, sure.
So as a reminder, Dremio is open source. We love to hear from you. Please join the community, ask questions, make recommendations or suggestions to us there. It's pretty active, and we're very responsive here, so it's a great place to connect with us. Dremio comes in 2 editions, the community edition, which has pretty much everything you saw today with the exception of the data lineage features and the LDAP and Kerberos support. And then we have Dremio Enterprise Edition, which has some advanced management capabilities, advanced security, and several other things that we make available as part of a subscription. And we're happy to talk to you about that and make it available to you to evaluate if you'd like. But the open source version is terrific. We're really proud, and we're just getting started. So lots of great things to come in the future. I want to thank everyone for joining today. A recording will be sent out to you shortly. I'm not sure how long that'll take me to put together, but we'll try and get it out to you very soon. And thanks for attending. We're going to be doing these every month. And so we'll be focusing on other deep topics related to Apache Arrow, related to different kinds of optimization techniques, advanced features we have with specific sources and specific tools. So stay tuned for future webinars, and we look forward to seeing you out there. Thanks again. Take care and have a great day. Bye-bye.